In this video, I'll be going over our first review lesson for Unit 0, our review topics. And this one is the properties of fractions, exponents, and radicals. So very first, we have our fraction operations, adding and subtracting. Big thing, just remember to add or subtract fractions, you must have a common denominator. As we see in our two fractions here, we have 8/3 and 7/4. And we got a common denominator of 12. Remember, we do that by multiplying the top and the bottom by the number that will give us the common denominator. In this case, 4 here and 3 on the other side. And then once you have the common denominator, you just add or subtract the numerators to get your final answer. Reduce as necessary. To multiply fractions, multiplying fractions is probably one of the easiest operations for fractions. And that's simply multiplying straight across. If you see that you can, once you've multiplied straight across, 8 times 7, 56, 3 times 4 is 12. If you see that you can reduce, you want to reduce if possible. Reduce if possible as on all of them. And then our last operation is dividing, and this is when we multiply by the reciprocal. Sometimes you may have heard it as keep, change, flip, maybe from your previous course. And so that is if we have two fractions being divided, we can go ahead and keep the first fraction, change division to multiplication, and then flip the second fraction. Now a lot of times we'll see this in terms of 8/3 and then a big division bar or fraction bar for the division. 7/4. This is actually more similar to what we'll see that in this class. We'll probably never really use the division sign, but instead be using our fraction bar to represent division. And so then again, that would be 8/3 the numerator times the reciprocal of the denominator. That's why I say reciprocal of the denominator there. And again, you just multiply straight through and you get your result. So let's go ahead and solve this equation in problem number 1. To be able to, using our operations to be able to isolate. Remember, solving, we have to isolate our variable. So we're going to go ahead and first minus 9/10 on both sides. Now, to minus 9/10 for this right side, I am going to need to change 4 into 4/1 to be able to actually do my subtraction. Now, since I am subtracting, I am going to go ahead and multiply by my common denominator, or what I need to do to get a common denominator. In this case, I would have 40/10 minus 9/10. Well, again, now that I have this, I can go ahead and subtract my numerators and get 31/10. So my result here would be 2/5 x equals 31/10. And then, since I have multiplication happening here between my fraction and the variable, I'm going to use division to divide that out. But again, this will be with our keep, change, flip that we had. So that would be 31/10 times 5/2. And again, we multiply straight across, and that would give us 155/20. But 5 can go both into the top and into the bottom, and that would reduce to, not 21, 31/4. And that would be our answer for problem number 1. So that is using a little bit of our fraction operations and a little bit of practice with solving equations. Next thing that we're going to be looking at is our exponent properties. Now here we have a lot of different exponent properties. Actually, I have a couple more out there. But let's go ahead and look at them each individually. We have our first one, which is if we have powers at the same base, we add up those powers. If we have a negative power, that becomes a fraction, or if I already have it as a fraction, that just kind of flips up to the upside, so that would become a to the x. So either way, a negative power, think about it as kind of flipping to the other side. If you have that fraction, flips to the other side. That's what a negative power does. Next one is our fractional powers, or rational exponents. And rational exponents become radicals. The denominator becomes the index of the root, and the power here is either can be written inside or outside, as we see there. So two options for writing that. Next one over here, we have a times b to the x, and we can see that, hey, x can come inside. Now, we do have to be careful. If there is, I'll go over here, this one is tied to it. If there is a power already inside and we are distributing that power in, then we are going to end up multiplying those two powers. We call that raising a power to a power. This one is raising a product to a power. So just a quick example, if I had, say, 2x squared to the third power, I could distribute that in, and that would become 2 to the third x 2 times 3, 6. And that would be a quick example of that. Here we have a very similar example. It's just now with division, x going into both. Over here, this one is very similar to our very first one, but this time we are dividing. So if we are dividing, we are going to subtract the powers. This is our inverse, not inverse, identity exponential property. Anything to the 0 power is 1. It's very nice. You can even have tons of crazy stuff going on. So it's raised to the 0 power is equal to 1. Very nice. This last property here, won't really see it. That is with absolute values there. We can go ahead and apply them. All right, let's go ahead and look at some examples here. I think I'll go ahead and do maybe I'll do A and C, I think. A and C, and then we'll move on. All right, problem A here. Very first thing I see a 0 power. Now remember, that 0 power means that this is equal to 1. Now 1 times 2 is just 2, so that is equivalent to just 2 n to the negative 2 to the third times m squared to the negative 4. Now as we saw in our properties, I can go ahead and take these outside powers and distribute them in. And that becomes 2 to the third times n to the negative 6, multiply those powers, times m to the negative 8th, again, multiplying the powers. But we have some negative exponents. We don't want any, so we're going to go ahead and rewrite this one more time. Flipping, remember negative powers flip to the other side of a fraction. We don't see a fraction, so we make a fraction. And those will come down. So our final answer will be 2/3 over n to the 6th times m to the 8th. And that would be our final result. So I said I'd go ahead and do C, so let's go ahead and look at C. All right, so here we have, and let's look at each side of the fraction individually. So I see, hey, I have the numerator, 2x to the 4th, y to the 3rd. Can't do anything there. Down the bottom, I have 2x squared, y to the negative 3rd, to the 4th. I can take care of this 4. So let's go ahead and distribute that in to each of those. And so then that will become 2x to the 4th, y to the 3rd, over 2x to the 8th times y to the negative 12th. All right. Now, if you don't see a power, the invisible power is 1. We have a bunch of same bases here, all being divided. And remember, if we divide powers with the same base, the powers get subtracted. So that'd be equal to 2, and then I take the 1 and 1 and subtract, so 1 minus 1, times x, and I have 4 minus 8, times the y's, and I have 3 minus, now be careful, I'm subtracting because we're dividing, but I also already have a negative here. So I could say minus negative 12, that could work. I'll show you an alternate way that that could be done, but let's do it this way. So that'd be 2 to the 0, 0, times x to the negative 4, times y to the, that becomes positive 15th. So we have a couple things we can do to simplify. First off, anything to the 0 power is equal to 1. And if I have a negative power, that moves to the bottom. So I have 1 times y to the 15th, so that's just y to the 15th, over x to the negative 4. Not negative, sorry, when we move it, it becomes positive. And that would be our result. Another way back up here, so I'm going to say another way that we could have done this one, is to take care of that negative power. I could have raised it first if I wanted to. And so then that would have been 2 to the first, x to the fourth, y to the third, times y to the 12th, that moved up, over 2x to the 8th. Oh, first there. So again, we combine, so 1 minus 1 times x, 4 minus 8. But now here they are multiplying, so instead of subtracting, we add them. y3 plus 12. But notice that that is the same as I had here. So it doesn't matter which way you do, you'll end up with the same thing. So that will be 2 to the 0, x to the negative 4, y to the 15th, resulting in the same answer, regardless of which method you did. All right, and that's a little bit of our exponent properties. All right, so let's go ahead and look at parts of a radical here. So parts of a radical, we have our index. That's not what I wanted. There we go. Our index here. The index is the number outside of the radical. That tells us what level of a root it is. Are we a square root? Now remember, if we have a blank number like this, square root of 25, square root of 25 is actually the second root of 25. Everything after that, we keep the index. We label, okay, is that a third root, fourth root, so forth. That will tell us what level of a root, how much are we breaking that apart. We have our radical symbol and our radicand. Some radical properties we have here. We have our first one, the square root of a times b, or any root. Remember, we can have any type of index there. But if we are multiplying, I can split that up into two different ones. So for example, if I had the square root of, say, 10, well, I can write 10 as 2 times 5, and so therefore I can write that as the square root of 2 times the square root of 5. That'd be an example of what that could be used like. Another one over here, very similar, but now with division. If I'm dividing a radical, I can split into 2. Now remember, we can go either way. So if I have 2 like this, I can write it as a single radical, and that can work. Or I can go from a single radical to 2. Same thing here. If I was given square root of 2 times square root of 5, I'd put it into one radical and simplify. We can go forwards or backwards with that. And then this is the same property we saw earlier with the exponent. So let's go ahead and look at some quick examples. Adding and subtracting radicals. To add or subtract, the radical must have the same index and radicands. What I mean by that, I can combine the cube root of 2. Let's see, this is adding. So adding to the cube root of, cube root of 2. So I can add these up, and that would be, I'd say I have 2 times the cube root of 2. Or if I had 5 square root of 7 plus 2 square root of 7, I could write that as 9 square root of 7. I have the same index and same radicand. And that would work. Whereas I could not combine, say, the cube root of 2 plus the fourth root of 2. I couldn't do that because they are different roots. Or even if I had, different indexes, or even if I had the same index, but I had different radicands, I can't combine those as well. They'd have to stay separate. All right, simplifying radicals. To get a radical in simplest form, we use a factor tree to break down the radical, or the radicand, and then look at the end of the branches and group alike numbers together according to the index. Notice square root has a hidden index of 2. We talked about that earlier. So bring the grouped number outside of the radical and multiply what is left as the new radicand. So let's go ahead and simplify this one here. So we have 3 times 8, or square root of 3 times square root of 8. So I can actually write that as square root of 3 times 8, which would be the square root of 24. Now I want to simplify that. So I'm going to break it up. I'm actually going to go ahead and break it back up to 8 times 3. I can do 6 times 4, 12 times 2, doesn't really matter. You'll get the same thing in the end. And keep on breaking up until you get to a prime factorization. So 8 is 2 times 4, and 4 is 2 times 2. Now you want to go with what the index says. So here I have a hidden index of 2. So I look for pairs at the ends of our branches. Do we have any pairs? And I do, right here, 2 and 2. So what we do is we take out from that pair, we take out a 2. And then anything left over is going to go back inside and multiply. So 3 times 2. So that is 2 square root of 6 as the answer there. Now again, emphasis on the, so these ones again, we're going back, on the index, because if I did the root of 24, but I made it a third root, that would be a different answer. So again, let's go to our prime factorization, 3, 8, 2, 4, 2, and 2. This time I want to find 3 of the same number, and there I have 3 of the same number. And I take out one of those out of the roots, that'd be 2 times the cube root, and then whatever is left over, in this case it is now 3, gets left inside. So that would be the result if I did the cube root of 24 versus the square root of 24. All right, I'm not going to worry about B. We're not going to see a lot of those. But here I have 8 to the 1/3. I can simplify this. This does have an answer. So let's go ahead, use our property with the radicals, because remember that means that that is the cube root of 8 to the first power. Well, anything to the first power is itself, so that'd be the cube root of 8. But now I can break it down according to my index. 8 is 2 times 4. 4 is 2 times 2. I'm looking for 3 of the same number. Well, there I have it, 3 of the same number. Nothing left over in my branches. So that is equal to 2, just 2. That is what has been multiplied 3 times. Let's go ahead and do one more over here. So that is 4 to the 5/2. So this one, 2 is our index, so that would be the square root, which I can go ahead and leave that blank, square root of 4 to the 5th. Now, this one is a lot easier if you go ahead and write it as a 5 outside. So I'm going to go ahead and do that. Well, this one we know, what is the square root of 4? Square root of 4, and again you can break it up, 2 and 2. There's our pair. So square root of 4 is 2, but that is 2 to the 5th. And what is 2 to the 5th? Well, if you multiply that out, 2 times 2 times 2 times 2 times 2 would be 32. All right, and that concludes these notes looking at the properties of fractions, radicals, and exponents. Thank you for watching.